All right, good day. Welcome to another episode of Adventures in Old Code. Let's see what we're doing today. Okay, last time we looked at fly. Today we get the wonderful program entitled Equ'n, which I'm sure is equation. In the old DOS land, you could only have file names that were 8 characters long. So that was my way of reducing that. Okay, let's have a look at equation. Here we go. Let's just run it. Ooh, point A. Okay, 30, 15. Point B, 40, 67. And there we go. Y equals 5.2x plus minus 141. And there's your x coordinate, and there's your y coordinate. Okay, this, okay, being trained as a math teacher here in the lovely province of Manitoba, I recognize this as part of the grade 10 curriculum for pre-calculus. And so that would have fit the time frame that I would have written this program in. Do I have a date on this? January 15, 1999. All right, so yes, I would have been in grade 10 still. I mean, this is still the first semester. And so this is the equation of the line. Excuse me. Given 2 points, figure out the equation of the line. And so I imagine, okay, let's do something in that range. 5 minus 5. Okay, so there we go. I'm sure I had questions on homework that would have involved this exact problem. And I'm pretty sure I can guarantee wow, what a phrase, that I didn't actually use this to answer any homework questions. What it probably did was I did my homework and then after the fact thought, maybe I can write that in QBasic. And sure enough, I did. So, okay, so if you don't understand what's going on here, 2 points on a Cartesian coordinate system define a straight line, and only one straight line. And that straight line is given in the form y equals mx plus b, m being the slope and b being a constant value. So that defines every line. Maybe you remember that from high school. Maybe you're still taking that in high school. Maybe you never took that in high school because, well, hey, maybe you never went to high school, and that's okay. Yeah, this isn't a very exciting program. It's just a bunch of numbers. Okay, so I calculate the equation of the line, and then I give you the values between the range of minus 5 through 5. So on that line, your x value is 2. Your y value will be 0.25. All right, let's see how I did this. Equation of the line, Joey Davis, January 15, 1999. I have m, x, y, and b as double. They're all double, so they have lots of decimals on them. M is the slope, X and Y are your variables, and B is at constant at the end there. So here we are. We're inputting point 1, accepting two values, x1 and y1, x2 and y2. Now here's the curious thing. This program does not use arrays, which is why we are looking at it now. But this could have used arrays. I mean, albeit it's only two values. But I could have had an X array and a Y array with each two elements. But that wouldn't have saved any typing. So I'm glad I didn't use arrays for this program, because that would have been overkill. All right, so I'm getting the x1, y1, x2, y2, and then I'm calculating the slope. Slope is rise over run, the difference of your y's divided by the difference of your x's. And that calculates my slope. And so my x, the x value, is m times x1, and my b value is y1 minus x. Whoa, what did I do there? Well, if y equals m times x plus b, and x is defined as m times x1, yeah, I can bring the mx to the other side. And remove this. So now y minus m times x equals b. X I'm defining as m times x1 here. Right, so now I'm looking for a specific, I'm trying to figure out the b. So these general xy value in this equation, I can make a specific. And m times x1, I've defined here as x. So I can replace this with x now. And there we go, b is y1 minus x. And that's what I'm doing here. And then I'm just printing it. Y equals m x plus b. Nothing intricate going on there. And then, oh, okay. So then I make this nice little chart, and I go from a equals minus 5 to 5. And then those are my x values, which I couldn't use x as my value because I used it up here. That's okay. So for a equals minus 5 to 5, just plug a into the formula and then print using print the x and then print the y. Yep. A was my x, and then y is what the final equation, what the formula spits out. So there we go. Not a whole lot to say about that. Huh. So I guess we could... No, you know what? This is... That's it. That's all I got. This has been a boring adventure in old code. But thanks for sticking it out with me, and we'll see you next time for more adventures in old code.